There are different explanations for what they could ask us to solve. They could be asking us to find x-intercepts. They could be asking us to find roots. They could be asking us to find zeros. Or in the instructions, they could say solve for x. And then they could give us a quadratic function. Those are all different ways of asking for the exact same thing. So there are different methods of solving a quadratic. Today we're going to talk about factoring to solve. Tomorrow we're going to practice the quadratic formula. In the past, in Math 2, I think you guys might have learned, if you got through the curriculum, you might have learned how to complete the square to solve. That's another method. And then once you have completed the square to solve, you can solve by taking square roots. There's lots of different methods. The two most common methods are factoring to solve and then quadratic formula, which is why we're reviewing those this year, just to make sure that they are fresh in your mind. And then probably the most comfortable method is graphing it on a calculator and just identifying what the x-intercepts are. Right? So if they ask you for an x-intercept, then the form that I would like you to put the answer in is x comma 0, because an x-intercept is a point that's like specifically appropriate for like a graph answer. But otherwise, if they ask for the root, or if they ask for the 0 of the function, or if they ask you to solve for x, for the rest of those, then it's totally fine to just write x equals a number. All right, so when we factor to solve, we're just going to start off with a quadratic, and the instructions could have been anything. So they could have said, find the x-intercepts. And if they said find the x-intercepts, then maybe our problem is y equals 3x squared minus 9x. And we just know that our method of solving is going to be factoring. So for us to find the x-intercepts, we're going to take this equation right here that is something that could be graphed, and we're just going to set it equal to 0. So I'm going to take the y, I'm going to replace it with a 0, and write 3x squared minus 9x. And if we think back to the last couple days of factoring, this is a binomial. It only has 2 terms. So when we think of binomials, we know that there's basically 3 different methods of factoring. We could have it's only a GCF problem, it could be a difference of squares problem, or it could be a sum or difference of cubes problem. So if you look at this problem, can you tell which it is? It's GCF. Okay, so look at the numbers. What number could we take out? 3, and then we can take out an x if we look at the variables. So we can take out a 3 between 3 and 9, and between x squared and x, we can take an x out. Okay, so now let's go ahead and look at what would be left over when we take that out. So for the first term, we took out the 3. For the second term, we had an x squared, we took out an x, so what is left over? An x, okay. For the second term, we had a 9, we divided out a 3, so what's left over? 3, and we had an x, we took it out, so we don't need anything else. All right, now this equals 0. So when you're factoring to solve, just a reminder, I'm going to walk through all the steps on this one, and then we don't have to show the steps on all the other problems because we won't be rusty anymore. But when you factor to solve, you're saying that this term right here times this term right here equals 0 once you've plugged a number in for x. So maybe you plug a 1 in, maybe you plug a 2 in, maybe you plug a 3 in. You just plug something in for x, and that when you plug something in for x, it's one number multiplied by another number, and that product equals 0. how do you multiply two numbers together and get 0 as an answer? How could you get 0 as an answer for multiplying two numbers? One of the numbers has to be 0, right? So when we do this, we say, okay, our assumption is that one of those numbers ended up being 0 somehow. So we say either 3x equaled 0 somehow, or x minus 3 equaled 0 somehow. That's called the zero product property. You don't have to know the name of it, the zero product property, but that's what it is. That one of those numbers happened to equal 0 when you plugged x into it. So if we solve this right here, what would we do to solve it? We need the x alone. Divide by 3. And 0 divided by 3 is 0. Okay, so if the x equaled 0, then that would have made a product of 0, and that would be a good solution for x. That would have worked, okay? Over here, how do we solve for x? Add 3 over x equals 3. Okay, so back in the day, the shortcuts that you memorized were that if the parentheses looked like this, then you just did the opposite sign. And then if it had a GCF in the front, that x value was just 0. Those are the shortcuts that we memorized back in the day. Okay, so now you don't have to show your work for these anymore. If you want to go back to those shortcuts and use those shortcuts for the other factoring problems, you can. Parentheses, we just do the opposite sign. GCF in the front, that x value is always just going to be 0. Those are our solutions. So here, factoring to solve, we have an x-intercept of 0, 0, and an x-intercept of 3, 0, because we're thinking about what would have happened if we graphed that. Okay, brains feeling good? Marvelous. Okay, let's try another one. With this one, we're going to say, find the roots of, let's say, x squared plus 11x plus 30 equals 0. All right, so what should I do here? Do the x thing, okay. Is this a slide divide problem, or is this one of the more simple ones? Simple, how do we know? There's no number in the front, it's just a plain x squared. So we're looking for what multiplies to 30 and adds to 11. Multiplies to 30 and adds to 11. 5 and 6. Okay, so in our parentheses we have x plus 5, x plus 6, keep the equal 0, and then we have two solutions. What are the two solutions? Yep, x equals negative 6, x equals negative 5. Done. Okay, feeling comfortable still? Yes, okay. Let's try instructions that say solve for x. This one is going to say x squared plus 3x equals x squared plus 25 plus 3, hold on, 2x. There we go. Okay. So what should we do? Say that again. Combine like terms. And what do these have to equal? Yeah. Do you like how I read your mind? We got to combine like terms. And we need it to equal 0 before we can do all the factoring, right? We have to have everything to one side. So how do you guys want to move stuff around? Move everything to the left? Okay. So what should we do? Okay. And then we can move the 3x over. If all we have on the left side is an x squared, and all we have left over on the right side is a 25, should we still move everything to the left side? We know how to solve this, right? Okay, now look back at the title of the notes, factoring to solve. Okay, factoring to solve. Okay, do we still want to leave the 25 over here if we're factoring to solve? No, we still got to make it equal 0, right? So it's very tempting to just square root both sides, but if we're doing that, are we factoring to solve? No, we're not. Okay, so we're going to move the 25 over. X squared minus 25 equals 0. And what type of factoring is this? Difference of squares. Yeah. So it's two terms, and when it's two terms, that tells us we have three options. It could be GCF, it could be difference of squares, it could be sum or difference of cubes. So we can tell it's not GCF, it doesn't have something in common. And then if we look at the types of numbers it has a perfect square, not a perfect cube. So we know that it's difference of squares. Okay, so we have two sets of parentheses, one with a plus, one with a minus. And I would say what I've noticed as a math teacher is that students are more likely to get this problem right if they factor it than they are if they square root it, because most students will say the square root of 25 is 5. What's the actual square root of 25? Positive and negative 5. It's both. It's got two answers, not just one. So that's why a lot of students get it wrong, because they forget there's two answers. They only think of the positive answer. When you factor it, you see both answers very easily, the positive and the negative version. So a lot of times it's better to factor these anyway, just because that way you won't miss one of the answers. Yeah. Okay, so x plus 5, x minus 5. And then the first solution is what? Negative 5. And the second solution is positive 5. Okay. All right, so with factoring to solve, it's just really important that we make it equal 0 and then are just careful when we factor. Okay. For today's assignment, you're not going to see factor by grouping, I don't think, or the sum or difference of cubes, just because those are not as common when you look at factoring to solve. You don't see those a ton. Okay. All right, let me get the assignment out.